Hi, it's Nick from Building Point Australia, and welcome to this StatiCa presentation on bracing cleat connections. And a question that comes up from time to time relates to controlling the angle of rotation of these connection plate components, and that's what I'll focus on today. We'll have a look at a few methods that you could potentially use depending on your situation to achieve the details you require. So let's move to the first example that I've got set up. It's a relatively straightforward arrangement. I've got a 200 square hollow section column in a vertical orientation and an incoming brace or strut. It's a 100 by 100 square hollow section, and if we attach a connection using a welded cleat to the column and similarly a welded tongue or cleat to the square hollow section, then we find that typically by default we'll have the cleat in a vertical orientation, and the question has come in a few times: how can we rotate that and have the cleat in a horizontal arrangement? Let's have a look at some options that we might try here. So selecting the operation tab from the design menu, we could try a range of different types here. Of course, we can always go back to a very manual setup, but we try to avoid that, simply for speed in setting up the connection details. We could arrange a plate and weld it to the face of the column, arrange it in whatever orientation and cut it and add welds and add bolt groups and so forth. Similarly, adding plates to the strut itself. But let's try some more automated operations, and we might try the gusset. We find that we get reasonably close with that, but we don't get control of the rotation. There's some details there that don't quite suit our requirements on this occasion, and similarly the fin plate operation isn't suitable here either. Let's try the connecting plate operation, and the setup looks reasonably close to what we want, except we want a different angle of rotation compared to that diagram there. And by default we get quite a deep welded cleat to the column, 250. I'll go to 120, and similarly for the width of the welded tongue there as well. So I could change the bolting arrangement so we have 2 or perhaps a pattern of 4 bolts. That's all in the bolting details, so I won't go to that at this stage. But something that might be relevant is the exact line of these members, and depending on the situation, applying some of these connection operations may shift the position of the member slightly, may shift the alignment. So something I like to just be aware of and try to control, particularly if we want to maintain the concentric nature of the connection, is this alignment. And going into a plan view and a transparent view on this occasion helps us identify that indeed we do have a concentric nature here of the strut coming into the column. The welded cleat on the column is off to one side, and the tongue is central with respect to the cap plate. And with that connecting plate operation, we could try some different details here. It might be that you want the plate to be on the other side. That's fine, it's the same sort of setup. We still have a concentric arrangement of the members. And we could also try some other details, such as a cap plate times 2. Now the tongue, each side slightly of the centre, that's fine. Everything is centrally aligned here, so that's quite a good option. I guess if that's the sort of setup you want, your bolts will be in double shear. And another quite nice option is a notched member like this. And there's a few other options there which I don't think would be used quite as much. The plate itself is notched in different ways, but the notched member is quite a good detail, fairly commonly used. And just to confirm the setup, I've selected this window, hovered over this welded tongue and pressed delete, and by rotating this around we see in fact the member itself has been notched as we require. As I say, there's some other details that don't do it quite in that way. All right, resetting the view like that. So that all gets fairly close to what we require, except we find that we can't control the rotation of this connecting plate operation. Something though that is interesting and we'll utilise is that we are connecting here to a new plate. By default, the software will do that, but we see we can also do a new plate ×2, so that's another option there. But we can connect to an existing plate. So this starts to give us some ideas of how we might go about this. If we have an existing plate, we could try having that on a different orientation and utilise that plate or member, say a flange of a column or something like this for the connection directly. So that's what we'll try. And by the way, in this connecting plate operation, we see that we're connecting B, the strut, to the column, and the related member is the column. And in fact, the orientation of this connection is based on the related to item. And so if we select that column and change the pitch to say 70 degrees instead of 90, we see that the cleat has followed the direction of the column, and the notched plate or the notched member in this occasion is moving within the cross section. So here's the horizontal view like this, and that connecting plate may also be perhaps a cap plate like this, and the orientation has been rotated in sympathy with the column pitch as well. So that might be something we would like to make use of at some stage as well. So let's see how we might utilise some of these options that we see in rotating the connection. So first of all, I'll go back to the 90-degree orientation, the home view, spin that around, and I'm going to untick, or we could right click and delete that operation there. So I'm going to actually turn on this stiffening member operation here. So I mentioned before that we could connect to an existing plate or an existing member, and that's what I've set up here is a member. So we've got a stiffening plate here and a stiffening member, and these are very similar in concept. It's simply that a stiffening member could be of a cross section, such as a universal beam, a parallel flange channel, a hollow section, or a custom shape of some sort, or a simple shape such as a solid rectangular section, and that's what I've used here. So I've got a stiffening member, and turning on the transparent view, it's of a suitable dimension like that. And so in the connecting plate operation that I'll use, I'll tick that on now. I'm connecting to the stiffening member, which I've renamed to rotate. It's just a clue for me to identify the item that I want to rotate when I want to rotate this connection. So we can right click on an operation and rename it like that, which I've done from SM1 previously to rotate. And so we see for this connecting plate operation, the one that I will actually use in this connection, it is connecting member B, which is the strut, to a member plate, and that is a stiffening member named rotate, and I'm connecting to the bottom flange. So this tongue is with respect to this stiffening member. So when I rotate the stiffening member like this, minus 25 degrees, for example, we see that the components rotate as desired, and minus 90 would be the typical arrangement that we would use. And by the way, I used a stiffening member instead of a stiffening plate here because we do have this option here to introduce a horizontal offset here. With a stiffening plate, we don't get that option. So that means that when we look at a plan view like this, that the stiffening plate set up as a rib with respect to this face of the column, it would be in the center, and it's then either shifting the tongue to one side or perhaps shifting the entire member, say 10 millimeters horizontally. So the stiffening member has that extra option in terms of the positioning such that we can achieve the details that we want. All right, so that's the first example. So just to finalise the position that we require, -90 like that. And of course, we could calculate this and make sure that everything is working fine. All right, the next option is here. And we've got a universal beam as a column, so a 410 UB60, grade 300, and a 360 UB51 as a rafter, and a couple of stiffeners on this side of the rafter. You would, of course, have them on the other side as well, but when we come to looking at this connection, I'm just keeping things a little bit clear, I guess, for clarity. Okay, and so this was a support case. A couple of questions very similar have come in to our support desk, and the question is, how can we use a stiffening item, a stiffener in the connection as a cleat, so to speak, for the incoming bracing members, and how can we rotate that? But when we select that stiffening item, we don't see any rotation opportunity here. So in that case, I'm going to untick that. By the way, we've got a stiffening operation here. Instead of it producing all four stiffeners, it's set to be the lower part only and on one side only. So hence the second stiffener operation to set that stiffener up previously. So I'll turn on this connecting plate operation, and here again we see quite a deep cleat, which I do want on this occasion, and I'm going to cut that back in a moment, and that will follow the direction of the brace here. And we see that I've set it up as the related member is to the column. So if we do want this vertical in line with the direction of the column flange, we can use the column as the related member. And the other option here is to use the rafter. This is on a 10-degree pitch, like this. So if we want the connection to be in that direction, parallel to the rafter itself, we could use that. But I want it to be vertical, so I'll switch it back to column. So this is somewhat interesting, I think, that we are using another member that's in the connection for the related to item, but I'm not actually connecting it. And in fact, by default, the face of that column, it's a little bit thicker, 7.8 millimeters compared to 7.3. So the full extent of that plate width would not, by default, reach the face of the rafter. And in fact, it's defaulting to the edges of the flange. So we need to extend that a little bit. So by right-clicking on this, we can use the editor, and you can see I've previously set up an offset here. So with plates, we can round corners, bevel or chamfer off corners, add holes and other details. Here I've added an offset, and I've made that offset negative 100 millimeters. And just to illustrate, if I take out a 0 there and apply that, we see it here, but it's not reflected in the model yet. If I apply that, we see that the width of that plate, it's only been offset 10 millimeters from the default position. So I'll take that back to 100 millimeters and OK on that. And it's sticking through the far side at the moment, and top and bottom we need to cut that back. So that's the purpose of the next 3 plate cut operations. It's simply this operation here. So switching those on. One is a plate cut of 6 millimeter leg fillets each side of the rafter web, and then also to the underside of the top flange of the rafter and to the bottom flange there. So that completes the connection on this side. We could look at the plan view like this. We can see that this welded cleat here is reasonably arranged above the flange of the column. If this member changes direction slightly, say 60 degrees, it's a little bit better arranged, so we can adjust some offsets and some angles and so forth to get this as desired. All right, let's go to the other side, where I'm going to illustrate a method that you could utilize if you wanted to control the angle even further and not have the angle of the cleats line up with any other member that's in the connection already. So I guess if we want complete freedom in the setup here, there's a way that we could go about it. It's perhaps not entirely perfect, and you'll see what I mean by that. We do have a bit of residual plate that's not going to be a real item in the connection, but I think that would have a negligible effect on the capacity and would be a reasonable way to go about it. All right, let's first of all turn on this stiffener operation. So just like these vertical stiffeners here, I've added another stiffener operation, but on this occasion it's a internal circular stiffener to this incoming member, which is brace from the south. And so we see it in the transparent view there, or in the solid view we see it here. A 4mm thick 3mm fillet weld on each side, stiffener using the profile option for the stiffener shape, and a cap plate option could also be used here, but if you want to use a cap plate later, then you've potentially got a double up on that item. So that's why I used a profile stiffener like this. And the purpose of this is that we want to have something which sets the direction for some other item, some tongues or welded gussets and so forth. So the next item I'm going to use is a negative volume here, and a negative volume operation can be set up. It's the bottom row of the operations list, and often you would use a shape such as a circular hollow section as a negative volume shape. You position it as desired, and then you can cut something else to that or position something else using that negative volume. So the negative volume itself is not real. So let's turn that on, and I again have renamed that to rotate. So we see it's a negative volume and it's a plate. It could have been a member shape, and I've got a thickness. Importantly, its thickness should be the same as the thickness of the tongue that we use later, and therefore the sides of the real cleat will line up perfectly. So we'll see that happening. So if you change the thickness of the tongue, change the thickness of the negative volume, everything works out nicely. And let's just add the next one. It's a stiffening plate, and we see in the transparent view that stiffening plate, the extent of it, it's actually coming through to the far side a little bit. And the purpose of the little bit of extra dimension there is this might be on a pitch, and I need a little bit more dimension so I can have a full weld down on this side. It's just a little bit arbitrary, but we're going to cut that plate in the next operation to the face of the rafter. And just to show that, I guess this might be a 15-degree pitch like this, and the plate is long enough such that we get full extent of weld down that cleat. All right, now let's just go back to the transparent view and the negative volume operation. And we see here that the stiffening plate is a doubler with respect to the negative volume. And if we rotate that negative volume to, say, 45 degrees like this, the stiffening plate rotates with it. It maintains that the orientation as it's a doubler. So that's the idea here, where we've set up a interior stiffener in the bracing member. A negative volume is a rib with respect to that, and then the real cleat welded to the rafter is a doubler with respect to the negative volume. So now we're finally ready to add a connecting plate. I've set up the details previously, and we see it here in transparent view. The same sort of details that I used before. Let's just right click on that and look at the editor. A handy option there is to look at the drawing option here to confirm the dimensions. that we've used, and the solid view. So we've still got a cap plate ×2. Let's just go back to a cap plate like that. And also we could look at any potential horizontal offsets and so forth, and make sure that we don't get an undesired lateral offset introduced if the detail defaults to doing that. So the idea of the negative volume as a rib in the centre with the same thickness as this tongue is that the cleat will be offset with respect to that, and this tongue is still central. And in fact, if we hover over that arc, we see that it is arc 16, and there's 64 arcs in this connection. And let's just get that angle right. And so the first arc is down here, and for the first quarter we've got 16, so this line here between arc 16 and 17 is represents the very centre. So this tongue is welded to the very centre of the bracing arrangement, welded onto the cap plate of course, and the doubler SB1 is off to the side. So that's part of the detail, I guess, of setting this up. It's up to you, of course, which offsets, if any, you're happy with. All right, and finally, we don't really want this interior stiffener here, so an option is to cut most of it away. So what I've got here is that stiffener 3, that was the first interior profile stiffener that I used on this particular connection, and this last operation cuts most of it away. So it's stiffener 3 cut by connecting plate 2B. I'll hover over that, and we see on the bottom left it is the tongue in this operation, and I've got a 70mm offset. So you could adjust that. If I only use 50 there, we see that the remnant is that big, like that, or a different value, of course. And by using 70, I only have a small sliver of that left, and being on the side like this, most of the action in this connection is happening near the tongue, and where that's welded to the cap plate, and the welds here. Off to the side here, it's doing very little, so this would have effectively no effect on the connection capacity. It's simply required to set up the arrangement here of the various connection details. All right, so getting back to the main point of all of this was we can now use this negative volume and change its orientation as desired, and we can rotate it completely and have complete control of the orientation that we require. And as I say, that item there is not actually real. It only shows up when we select the negative volume, the rotate option here, and we're left with these remaining details. All right, as always, if we can be of any assistance, please get in touch with us at Building Point. Thanks very much. Cheers.